The resistor is a small component you've seen 100 times on your electronic board. It may look like nothing, but it's an essential component keeping everything running smoothly. In this video, we will discuss what a resistor is, the different types of resistors, applications in which we can use our resistors, and how to determine the resistance of a resistor you intend using in a project. Resistors are fundamental components that control the flow of electrical current in various electronic devices and circuits. Resistors can be grouped depending on their material, construction, or purpose. The main types of resistors are fixed resistors, variable resistors, and special resistors. Fixed resistors have a constant or fixed resistance value and are commonly used in electronic circuits. Variable resistors have resistance values which can be adjusted. Examples include potentiometers and rheostats. Special resistors have special purposes. For example, thermistors change resistance with temperature, varistors change resistance with voltage, and photoresistors change resistance with light. This video shows some of the types of resistors previously mentioned. First, we have the potentiometer and variable resistor. Next, we have our fixed resistor, and finally, a special type of resistor, the photoresistor. Now, let's take a look at some of the applications of resistors. Resistors are used to limit the amount of current flowing through a circuit, protecting sensitive components from damage. Resistors can also be used to create different voltage levels within a circuit, essential for biasing active components and creating voltage dividers. In addition, they help shape and modify signals, ensuring they are compatible with the rest of the circuit. That is, they can be used to attenuate, amplify, or filter signals. Resistors can also be used as heating elements in devices like toasters, ovens, and heaters, where the resistance causes the resistor to heat up. Lastly, resistors are used in multimeters to measure current, voltage, and resistance. Certain types can also be used to measure temperature. Let's take a look at some of these applications in a short demonstration. In this video, we will demonstrate how a variable resistor can be used to adjust the brightness of an LED. To build this circuit, we will use a potentiometer, a blue LED, a breadboard, some jumper wires, and an Arduino Uno to provide 5-volt power supply. To build the circuit, place the potentiometer on the breadboard and do same for the LED. Connect a jumper wire from the negative power supply of the breadboard to the LED and the positive from the potentiometer to the LED. Tap the positive supply to the potentiometer from the 5-volt output of the Arduino Uno and connect the ground to the breadboard as well. Connect your main power supply to the Arduino board and the LED turns on. Adjust the knob on the potentiometer to increase or decrease the brightness of the LED. This is a cool feature you can use in building projects. Next, let's see how a resistor limits the amount of current flow, thus protecting a sensitive component like an LED. To do this, we will build 2 circuits for lighting an LED, one with a resistor and one without a resistor. We will need 2 LEDs, a fixed resistor, a breadboard, a battery for power supply, and some jumper wires. Let's build our circuits. Connect the blue LED to the breadboard and the fixed resistor between the positive supply of the breadboard and the LED. Next, place the red LED on the breadboard. Connect a jumper wire from the blue LED to the negative of the breadboard and do same for the red LED. Connect the battery terminals to the positive and negative of the breadboard. The blue LED lights up. Watch what happens when we connect a jumper wire from the positive of the breadboard directly to the red LED. The light goes out. But how do I know if the resistance of my resistor is okay to carry out this function? Let's look at color coding and how it can help you choose the right resistor for your project. Resistors have little colored stripes or bands on them that tell you their value. Generally, 3 of these bands are grouped together as one end of the resistor. This is followed by a gap and then a single band at the other end of the resistor. The single band indicates the accuracy of the resistor value. The resistor value itself is determined by just the 3 bands. The first band is the first digit, the second band is the second digit, and the third is the multiplier band, which tells you how many zeros to put after the first 2 digits. In this example, the first band is the color brown. Cross-referencing with our table, brown has a value of 1, hence the first digit is 1. The color of the second band is black, which from our table has a value of 0, hence the second digit is 0. The third band, which is the multiplier, has the color red. From the table, red would be 10 raised to the power 2. That is, the first 2 digits are multiplied by 100, or 2 zeros are added to the first 2 digits. Hence, the resistor value would be 1000 ohms, 1000 ohms or 1 kilo ohm. The fourth band, which determines the accuracy of the resistor, has the color gold, which from the table is plus or minus 5%. Putting all this together, the resistance of our resistor would be 1 kilo ohm with a 5% tolerance.